All right, ladies and gentlemen, a couple things I wanted to go over here related to these word problems. I'm going to go through the first three. And just like the examples we went over yesterday, where depends on what you're given, how are you going to go about finding the equation of the line? It's going to be this exact same thing for these word problems. And so they're called slope-intercept equation word problems. We're going to write an equation in slope-intercept form. Y equals mx plus b for each of these examples. All right. And it says, write an equation to represent each scenario below. Start by identifying what two pieces of information is given to you, including a slope. Is it your y-intercept, a point, maybe 2 points? And just like our other examples, depending on what we're given, that's how we're going to find the equation. All right. So let's start with example 1. It says an airplane 30,000 feet above the ground begins descending at the rate of 2,000 feet per minute. Assume the plane continues at the same rate of descent. Now, I like to draw a picture. It's going to be an absolutely terrible picture, no question about it. But got a plane. That plane turned out especially bad. Not sure what I was drawing there, like an aardvark or something. All right, good enough. That wing's awfully small. Really big possibility of crashing. Anyway, it starts at 30,000. Now, obviously, it doesn't start at 30,000 feet. The plane has to get up into the air. But that's not what the problem is giving us. It's basically saying it's starting from 30,000 feet, and it's only dealing with the descent, as in it's going down. Check out the problem. Everything is about its starting place in the air and its descent. It's descending at this rate, and what if it continues at this rate of descent? Everything is about it going down. Oops. All right. So technically, this is our starting value, or our y-intercept. Okay. And then it says that it comes down at 2,000, a rate of 2,000 feet per second. All right. There's a key word there to tell you whether you're seeing the slope. Is this the slope? Is this our growth, or whatever you want to say? And it is, by the way, descending, so make sure it's a minus. And it's the key word is rate. The key word is rate. This is another word, if you remember with the bicycle, the rate of the speed, basically. That's what this is, the speed, the rate of change. How fast are they changing? In this case, it's negative, it's going down. So this is the slope. All right, so let's fill in what we have here. We're given the slope, which was minus 2,000 feet per second. And we're given the y-intercept, the starting value, which is 30,000. And we have everything we need to create the equation, right? M is our slope, that's negative 2,000. X, we always have that X there by the growth or slope. I forgot the minus, give me a second. Right? Plus 30,000. Now, if this doesn't make sense to you because you're like, wait a minute, I thought they started at 30,000 and they're going down, why are we adding? You can also write this as, some of you might like this better, which is y equals, here, let me do something here, actually, or y equals 30,000 feet, and then you're taking away 2,000 feet every minute. So there you go. That might make a little more sense to those of you who are looking at the situation and going, why are we adding? Well, we're not. We're starting at 30,000 and then taking away 2,000 every minute, feet per minute. All right. So either way you write it, you have everything you need, the slope and the y-intercept. And you can see each piece of information is kind of by itself. It says 30,000 feet, 2,000 feet per minute. You'll know a point when you see it. All right. So we have our slope, we have our y-intercept. All right. Cool. Let's go to example 2. But like I said, don't overthink it. If you have the rate of change, look for that word rate. Rate is often seen. Also, another thing that tells me about the rate is this right here, feet per minute. It has more than one unit. Think about what slope is. It's change in y over change in x. It has it's comparing two different units. So not only the word rate, but the feet per minute also tells us, hey, this is the slope. All right. So a couple keywords there. You're going to see that again right here. It says Marty is spending money at the average rate, right there, average rate of $3 per day, dollars and days. That's your slope. I'm going to just tell you right now. Word rate, the dollars per day, money per day, that's 2 units, money and days. The slope is 3. All right, what else are we given? It says after 14 days, he has $68 left. Now, this is obviously not the starting value. This is 14 days later. It looks like he's spending money, but how much money did he have at 0 days? How much did he start with, money-wise? And so this 14 days and $68 left, that's obviously not our starting value. We want to know our starting value would be 0 days. So you can see these kind of come as a pair. And so what we have is a point. That'd be 1468. All right, and you can see the information is in the same sentence. It comes in a pair. And think about if this dude's spending money, how much did he have to start? How many did he have at 0 days? Obviously, he had a decent amount. He's losing 3 a day. And after 14 days, he still has $68 left. So we know he's going to start with more money. He's losing 3 a day. So actually, our slope is -3. So just be careful. If you're losing money, minus, keep those things in mind, right? So our equation, how are we going to do this? Well, we have a slope and a point. We need to find the starting value. Right? How are we going to do that? Well, when we have a slope and a point, you guys know this, we always go to y equals mx plus b. We're going to fill in everything but the b. The b is our y-intercept. We need to find how much money this dude started with. All right, and the way we're going to do that, we have a point, and so 68 is my y. Slope is -3. 14 is my number of days there. That's my x, and we want to find how much this dude started with. All right, a little bit of math here. 14 times 3, -3. It's going to be -42, so 68, -42. You guys can hopefully see where this is going here. We're going to add the 42 to both sides. Oops, don't know what happened there. Add the 42 to both sides. I'm just going to do it here, and you get $110. All right, now I didn't show that adding the 42. I hope you guys didn't realize what I did there. I added 42 to both sides. You get $110, and that makes sense. If he's spending money and losing $3 a day, if he started at 110 after 14 days, he's down at 68. That makes a lot of sense. He'd have less money at 14 days. So this makes sense. All right. All right, cool. Last one. For number 3, it says, suppose a 5-minute overseas call costs $5.91 and a 10-minute call costs $10.86. So right here, even though it's all one sentence, there's like this split in the sentence, right? There's 5 minutes at $5.98 or $5.91. So 5 minutes at $5.91. And then it splits to another piece of information. 10-minute call costs $10.86. Okay, a couple of things we don't know here. We don't know how much it costs just to pick up the phone, How much did a 0-minute phone call? Just make the call. Is there a starting value? Maybe it's 0, maybe it's not. How much money per minute did we spend? So we don't have the y-intercept, which is our starting value at 0 minutes. We don't have how much money it costs per minute. All we have is 2 points here. And look, the information comes in pairs. It's like an ordered pair. So we have 2 points. 2. One is 5.91, and the other is 10.86. You can see it's almost like $1 a minute, right? If 5 minutes costs almost, around $5, 10 minutes cost around $10. We're looking at, just generally about $1 a minute. We can kind of guess that here. But when we have 2 points, in the end, we need the slope and the y-intercept. So we're going to need to set that up to find slope and y. And so this is the hardest one. So actually, I'm going to come over here and write it and copy and paste my picture in. 2 points. What were they? 5.91, and 10.86. I'm going to check that 86. Confident, good, all right. And we need to find the equation that represents, our starting value. How much money did it cost to pick up the phone and just dial the number at 0 minutes? And how much did it cost per minute? So the slope is going to give us how much it costs per minute. All right, my y's are 10.86 and 5.91. My x's are 10 and 5. All right, calculate. All right. And with word problems, decimals are totally fine. Hey, look at that, 99 cents a minute. I was pretty darn close. So our slope, and you don't really need labels here. It's nice to know, though, that what we found was it's 99 cents per minute. It's the slope. And so it has two units, change in y over change in x. We're dealing with what our x's were minutes and our y was money. Hey, that makes a lot of sense. 99 cents per minute. All right. Second step. Extend my page a little bit. Now we have a slope and we have some points. So I'll use the smaller points. 5.91. 0.99 is my slope, so that goes in for my m. Sorry, let me write this. It's y equals mx b. So we need the y-intercept, the starting value. That's what I'm doing here. All right. So plug in everything but our y-intercept, the letter that represents it, the b. I used this point right here. Why I switched colors there, but I use that point right here along with my slope. And let me go ahead and finish this out here. So 99 cents times 5, 4.95. And then subtract that. So 5.91 minus 4.95. So what does this mean? Again, we're not really worried about the meaning, but it's kind of nice to know. This is at 0 minutes. If I pick up the phone and dial the number, how much is it? So it's 96 minutes, or I'm sorry, 96 cents just to dial the phone. 99 cents, 96 cents just to dial the phone. And then it's 99 cents for each additional minute. This is the starting value. So there you go. You need to write the equation, which would be, let me go ahead and come over here and write it for you guys. That would be y equals 0.99x plus 0.96. Decimals are totally fine here because we're not really worried about the graph. We're worried about the actual word problem, the real world stuff. And in the real world, decimals make way more sense. I mean, we're dealing with money. You don't want to say, costs 99 1/100ths of a dollar to somebody. You want to say 99 cents. So it makes sense to have it as a decimal. All right. Ladies and gentlemen, the rest of these examples all follow this formula or this format. If you are able to find a rate, you have a slope. If you find the starting value, great, you're good to go. If you find some points, you might need to do some math to figure that out. All right. Take care, ladies and gentlemen. Thank you for tuning in and finish these other 4.